Guys, you're all aware that all our lectures are being live broadcast on YouTube. So if you want to review it, those live recordings are there on the YouTube immediately. Later on, I replace them with cleaner versions of the recording, more edited versions. But if you want to immediately access them, all of the recordings are there on the website. No, sorry, on the YouTube channel, Support Vectors. So with that, I think it is one more minute to go. We should I'll start the recording now, guys. It's Does anybody have a question from yesterday's session before we start? Could one of you confirm that you can still hear me?
Yes.
Yes, we can hear you.
Excellent. So what I'm going to do today is use, today's topic will be pandas. In data science, we use pandas a lot, and NumPy, making arrays, etc. a lot. As we make progress with data, I'll explain some basic operations that you should do with data, clean it out, and so on and so forth. There is also the concept of tidy data. Tidy data is a concept that says if you can put data in a long format, then any kind of manipulation you want to do with the data becomes easy. There is a very close analogy between this and SQL. In SQL, if a data can be represented as a table, then writing, and even there, if it is in a good format, then doing joins, doing filters, and picking a few columns and aggregates and this and that and group bys, you can achieve a lot with a very succinct syntax, which explains why SQL has been popular now almost for more than 40 years. I think it's the history of that. I don't remember the exact amount, but it's almost 4 decades since it's been around. A similar thing is true for the data frame. When we create a data frame in pandas in Python, and pandas is obviously the default way we do it at scale, we do it as a data frame in Spark, let us say, or in Flink or something like that if we are dealing with streaming data. But today we are not going to focus on streaming data or a large data set. We're going to focus on pandas. So in pandas, when you have a data frame, and by now we are all familiar with what a data frame looks like. It is rows of data. Each row has multiple attributes. Then we can actually do any kind of data manipulation with a very small, what people call the grammar of data manipulation, tidy data and its vocabulary or its language for manipulating the data. It's a very small vocabulary it contains, as you will see. If you understand that vocabulary, any data that you encounter, you can go through a systematic process of canonizing it, standardizing it, manipulating it, getting what you want out of it. Today, we are going to focus on that. Now, those of you who have taken ML100, you will find that in the tabular data chapter, there was a whole section on this. Perhaps I should just start by referring you all to that chapter, and then we'll go into the code, and I'll walk you today through code, explaining the concept of tabular data. So if you go to, where do we go to? Support Vectors website, vectors.com.
Are you sharing something?
So, Asif, are you sharing your screen or?
No, I didn't start, but it's a good time to start.
Oh, okay.
Let me start sharing now. Here we go. So I am now sharing my screen, hopefully. if we go to supportvectors.com and the ML100 that you guys took, the very first link here is obviously one is the Slack channel. The very first, and by the way, those of you who took that know that all your YouTube videos are here. So it's hopefully a good reference for all of you. You can go back. How many videos are there? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, about 17 videos are there that may help you review the topics that we talk about. But there is this book.
Asif, it is still not like I'm not able to see the sharing.
Oh, you're not able to see the sharing. Quite interesting. Why is that so? Let me see what's going on.
Yes, Asif. Me too. I'm not able to see the screen.
Tell me if we have better luck.
Yeah.
Okay, so
now it's better.
See, there is this page. Those of you who took ML100 with me recently, you remember that all our notes are here. Just a refresher that this is the textbook for ML100. All my lab works are here. We'll go through this again in a moment. It will remind you. Then we missed the first lecture. If you remember, the first lecture was just getting set up and orientation, etc. So I didn't record it. But thereafter, all the other lectures are here. For example, this was in the pre-COVID world where we were holding the lecture in class. And right after, all the future lectures are, as you can see, we do it remotely or we do it virtually. So all of these lectures are here. There are about 17 of these. So in ML100, we had 17 lecture sessions. And I intend to create another page today, maybe not today actually, sometime in the coming week for ML200, so that you'll have one page in which you can go and access all the lectures that we have had, all the sessions that we have had so far for ML200. But here I'll refer, and this is obviously a Slack memory or network data, tabular data. So the three kinds of data we deal with are tabular data, that is as a data frame, which is the context for today. Network data, we touched upon network data in ML100, which is of growing importance these days. LinkedIn, for example, is a professional network. Facebook is a social network, and so on and so forth. Network data is everywhere. Then, this was the book that we, those of you who were, are you familiar with this? Does this look familiar, guys? Does this look familiar, these notes? Anybody?
Yes, sir.
Yeah, it's looking familiar. Right? So this is straight from your, and this is shared with all of you with ML this summer, or just or in the spring. So here I will go in particular to this concept of tidy data. Remember, I'll just give you a review of tidy data. And those of you who did not attend this summer, it would still be useful. But before I do this, let me take you guys through something that you'll find very useful. In fact, since I'm talking about this course, let me go to this helpful resources. This contains tips, cheat sheets, documentation, glossary, bibliography. Glossary is somewhat sparse, but okay, let's go through this. It may be useful here. So first of all, basic tips on plotting. A principle that you should use the listing, that you should use ggplot, right? And how do you embed LaTeX fonts or LaTeX into your thing? We covered this last time. How can you have a plot in which you can do fancy stuff, you can do annotations, you can or have a production quality plot. Right? So these are tips that you'll find in this book. How do you create a multi-plot, a grid of plots? So there's sample code here to make a grid of plots. It's very easy. And oh, by the way, this should be, in pasting it here, the formatting was lost. It should be indented. So that's that. The next thing I do is our helpful cheat sheets. See, we live and use a large ecosystem of life. Data science world is interdependent. You will create artifacts that other people will use. Your code, your analysis will be useful to somebody. At the same time, you take help from a lot of resources that are available. So this is a collection of cheat sheets. This is for the R library, those of you who are doing it. And I find that these cheat sheets are actually very good. For example, ggplot. Right? If you click on this thing, you will see you get this very detailed. Is there somebody asking a question? I missed that. So this is, anyway, I find it very useful. So one of the things I do is I traditionally would print it out on long format paper and paste it on the wall. And just, as when you're doing this, it is quite convenient actually, just to be looking around and seeing it there. One trip that somebody used to do, which also is very good, what they would do is they would put it on the table, all these cheat sheets, different cheat sheets for all the things they use, and then they would do something interesting. They would put a glass on it, a large sheet of glass or a slab of glass, so that they could work on their table and literally they don't have to look far for hints for the reference. The references are literally staring them under their nose. And I found that to be very useful. In fact, I'm meaning to do that. But it's very useful. See, you will know all these things, but are they available on the tip of your finger? That's what these cheat sheets do. They make it available. They're not ways to learn it, but once you have learned it, you can quickly refer to it. Right? Like, for example, this is data manipulation. This is what we'll talk about today, not in R, but in Python. But you can clearly see from the picture what it is doing. This is filtering the data, looking for distinct values, so on and so forth. So these cheat sheets are very useful. Anyway, my personal tip would be print them out or use whatever you're the younger generation. Maybe you never print things, so do as you please. So this is the pandas reference. We'll pay some attention to it today. That's a topic. Are you guys able to see this pandas reference on the screen, guys? Is it visible?
Yes, it is visible.
So one of the things we will deal with today is pretty much things that you find in this sheet. Right? We will use most of it today. Importantly, we will talk about the reshaping of data. When data comes and it is in a shape that we don't like, how do we make it into a tidy data format? Right? It is the foundation, as very well it says in this cheat sheet, a foundation for wrangling in pandas. Tidy data was created by Wickham in R actually, in a very influential paper he wrote on how data should be manipulated. Before that, people were achieving the results in all sorts of haphazard manner, manipulating it, hacking it, and so forth. When he wrote his work on tidy data, it showed, and he came out with the dplyr library, which is hugely influential in R and influenced pandas quite a bit. Then obviously, you can see, you can tell people who are used to tidy data and people who are not. The people who are used to tidy data, you can very clearly see their data analysis. It is very ordered, very structured, and very exactly what you would expect. And very in a few steps, they manage to massage or wrangle with the data into the form that they want to put it. Right? It's a very short journey. So it is worth knowing. So today, from a Python and Pandas perspective, this is what we will do. So how do we shape the data? Right? Let us go through all these steps. Then there's data summarization we'll talk about. Basic summarization of data is what? Count the values in a given column. So for example, if you have one of the columns is cities, you would want to know how many cities are involved. It's very simple. You do values count. A question that keeps coming up is, what is the length of rows in a data frame? So quite often I see people do a data frame dot shape, and you pick then that shape is well, it's a list, like rows, comma, columns, and then you pick the 0th row. That is also true, that works, but a shorter syntax is literally to ask for the length of the data frame. It will tell you. If you want to find how many distinct values are there in a column, once again, you can do that. This is very common. Like, what is the difference between unique and value count? Unique will just tell you how many cities are there. Value count will tell you for each cities how many sort of rows are present, right? So you can say Chicago, there's 200 rows present, and for San Francisco, 50 rows are present, and so forth. Right? A summation, again, summation, min, max, mean, variance, standard deviation, median, quantile. These are standard descriptive statistics. So you can do that quite literally, as you can see, in a direct way. It supports that. Now, you have the apply method. If you want to do a transformation of a row into something else, or of a value into something else, apply is sort of your Swiss knife for doing it. Very, very powerful. It can do a lot of things for you. Then, some of the things we have been encountering are a drop not available. So you want to remember that if you are rich with data, you don't mind dropping a few rows where data is incomplete or some column values are not present. You can do drop a day. Excuse me, today I woke up a bit late. I'm still yawning. Okay, so a fill NA will fill missing values with some fixed value, and then there is a whole technology of data imputation. Right? If you don't want to just fill it with a constant value, what do you want to do? There's many imputation techniques which are more powerful. We'll leave it as that. How do you make a new column out of data? This is one of the first things people ask. Suppose you have data, in our case, let's say in the California housing data, latitude, longitude. And from latitude, longitude, somehow you want to find distance to San Francisco or distance to Los Angeles. How would you do that? And the answer to that is, let's say that you have some computation that you can do, right? That would be, you can do it, and then now you can create a new column. Or here is a simpler example, actually. Actually, I like this example much better than what I said. Suppose you have a column called a length and a column called a height in your data frame. So you see this column. And you want to add another column, this green column, which is the area. Right? Area of, let's say, something. So wall, let us say, length and height of a wall, and then what do? You can use a syntax like this. You can create a new column, lambda data frame, such that length times height. For each element of the data frame, you do this. Right? You could do it in a different way, which is sort of an implicit way. You could just say, you could do it this way, and you have seen me do it this way, the second way. And the other thing you can do is you can bin data into n buckets. So so basically it will make it discretize the data and so forth. Next, there are many things, min, max, the max of the row, and so on and so forth. I won't go through every one of them. Let's combine data sets. Suppose you have two data sets. What can you do? You can, well, you can merge, let's say that ADF, A data frame and B data frame are X1, X2, and this is X1, X3. One of the things you can do is you can join the standard SQL join. You can join based on the column. The common column is X1 here. If you observe carefully, X1 is the common column. You can join on that, right? When you do join, there is a concept of inner join, outer join, and when you do outer join, it can be a left outer join or right outer join. Those of you who are familiar with data manipulation probably know it, but I'll just iterate it. The inner join will keep only those rows of the data which are present. Like if you take a key, a join column, a key, these are called the join keys. Right? So this X1 is common to both. So you notice that ABC, ABD. So what are the two common rows? A, B, the first and the second row. So if you do an inner join here, you notice that the first and the second row are kept. If you do an outer join, full outer join, then it doesn't matter. It will keep uh, rows from both the tables. So it would mean ABC, ABD put together would become ABCD. So you see ABCD, right? Now the problem is that this one doesn't have a X2 value for D, and this table doesn't have a value, X3 value for C. So those would be replaced with nans, not a number. Right? NaN is not a number. But you could choose to say, keep the ones on the left, must preserve the ones on the left and outer join. So then you have ABC here, but D gets dropped because the D is not present. Likewise, you could do a join on the right. When you do a join on the right, let's look at it. It is ABD. So C won't be here. And here we go. We have ABD, but C is not here. Right? Observe something interesting. Whenever you do a left, right, or outer join, do you notice the presence of nans, not a number? In other words, the value is not present because the other table doesn't have it. And so you develop not a numbers. Inner joins, if you start with tables that don't have nans, then the inner join will also not have nans. Inner joins ends up with the least number of rows. Full outer join would end up with the maximum number of rows, and then the left and the right left and the right outer joins would be somewhere in between in terms of the number of rows. Right. Again, guys, if you are familiar with SQL, this is a direct translation from that. Then you could do a further filtering joins, which is a bit more sophisticated. You can say that given a data frame, preserve only those rows where X1 is in the other guy's X1, right? So you're filtering the A data frame based on a criteria on the other one. This is a bit more advanced, so let me not go too much into it. And you could do the opposite of that. Say, exclude the ones that are common, keep the ones that are not common, not present, and so on and so forth. Right? This is it. You could also do set-like operations. What are set-like operations? Remember, sets do not contain duplicates. Right? So if you do a merge of a Y, so look at the Y and Z data frame, ABC, BCD. If you do a merge of the rows, you will end up keeping only the intersection. So the intersection between ABC and BCD is, of course, B and C. So B and C are preserved. So the outer merge, of course, preserves from both, as you can imagine. Now, when you do this set-like operation, remember that the other column has to be the same, right? So these are, anyway, we can go and talk a bit more about it, but let's come to group operations. Group by is very, very common. So suppose you have a lot of data. Let's take the example that we're going to deal with. Suppose you have a bunch of cities, about 20 cities. For each of these cities, you have a lot of data, temperature data. There's a column called temperature. You don't want to compute the average temperature across all the cities. Maybe that is of some value. It will tell you something, baseline. But you're much more interested, perhaps, what's the average temperature or the median temperature in a particular city by city. So how do you group the data by all the temperature data by city and then take the average within that group, right? So when you group by cities, then for every city, there will be a group of temperature data, and then you take the average or median or whatever it is that you want to do, and it would be specific to that particular group or that particular city. So those are group by operations, extremely powerful, again, coming directly from SQL. Then Group by is here. Aggregate, sometimes you can just aggregate directly by giving what do you want, median, mean, this and that. You don't need to do group by and then sum, right? Or something like that, or median. You can directly use the aggregate function. So this is the richness of these APIs, but we'll see it in action in a moment as a Jupyter notebook. Huh? So then you can have all this value shifted by one. There are many, many things, cumulative maximum, cumulative minimum, and so forth. We won't go into all of those, but this is it. And now, as you know, one of the big things that has happened with the latest pandas is in the pandas data frame, there is a very tight integration with matplotlib and other plotting libraries. So you can do, you notice that these are things that come from matplotlib. They are directly integrated. So you don't have to separately call. You can on the data frame itself say dataframe.plot dot whatever kind of plot you want, histogram, scatter plot, and this and that. One more powerful thing that came into data frames, just as a reminder, under data frame is the fact that you can plug in the backend now. Some people find matplotlib to be rather vanilla looking, rather meh looking. Then they want to put in fancier backends. For example, if you want interactivity, you don't directly get interactivity with the matplotlib. You can bring in interactivity with Bouquet. And we did that, if you remember, in a previous lecture. We created a plot that was interactive. You could zoom in, zoom out. You could see the value of each point in the data set and so forth. So all you have to do is, in the preamble of your data, you have to just specify that you're using the Bouquet backend. Do you remember, guys, that one line? I think the notebook that I have shared in Slack has that example there, and we did that in the class. Anybody remembers that?
Yeah. So Bouquet is a library abstraction of on top of Matlib, right? Or Matplotlib.
Yes, it brings in interactivity. Actually, what they do is they use JavaScript actually.
Yeah.
So they don't produce static images. They do it in JavaScript. Another one is Plotly. Plotly is actually a commercial library, but they have made sort of a suite, a part of it available in open source. Usually, like for example, Plotly is sitting upon D3. D3 is perhaps the most powerful data visualization library in JavaScript. It's a huge, huge following. Plotly is based on that. The good news is that makes it very sweet and powerful. The bad news, I don't know if it is a bad news, but I'm usually very skeptical of companies that will sell you one version of the product free and then another version of the product they'll charge you for, because sooner or later they'll start restricting what's available in the open source version. So I have been a bit skeptical, but maybe my skepticism is not justified. Anybody who has more experience with Plotly can speak up. But here's the beautiful thing. All you have to change is the backend. The Pandas plotting API remains the same. And just with one line of configuration change, you can flip from one to the other. And that is a powerful thing to do. Like one backend to the other. So this is a basic landscape that I'm going to cover today. Let us do that. I'll start my Jupyter notebook. So, and I will take the example of the weather data because there I think I have worked out deliberately a situation which required pretty much all of these things that you have seen here. We'll need to reshape the data and make it into the standard format. We'll have to do groups. We'll have to do group bys. We'll have to do some manipulation and adding of columns and so forth. So let's try that example. So let me start Jupyter. There we go. There's a few who have read the book, the exploratory data analysis book on the tabular data. You're familiar with it. But anyway, I was talking about the cheat sheet. Let me finish the discussion. These are the cheat sheets that I use, guys. So I just put the ones that I use fairly extensively. And I am inspired by seeing my friend put it on the table and put glass on it. I intend to do that. I haven't quite done that, but it's useful. The R comes with a lot of documentation. There's a website of documentation. R is probably one of the most well-documented languages, and now Python is trying to follow that tradition. You have very good quality articles explaining every library. And there's a journal. By the way, this journal I highly recommend that you guys read if you are doing coding with R. If you look at this journal, it is not, so let's look at the current issue. The current issue talks about all of these new techniques and R package for bi-clustering, fitting tails or modeling regimes, and R package for computing duration-based quantiles from the Cox proportion hazard model. So people are announcing new work quite literally here. So here's the thing, and this article is worth reading, a landscape of R packages for automated data analysis. Let's go and look at it for a moment and see the quality of the article, because on the internet, the quality of articles are pretty varied. So guys, when you look at it, do you realize that it speaks to a high quality? It's been well written. It has an abstract. It's written in tech, sort of, or exported to tech, most likely through our markdown. And they are talking about all of these libraries that some of it you may know, some of it you may not know, right? And just by looking at it, what do you conclude? The most popular libraries are Data Explorer. This is the one that I had recommended. And now summary tools. Summary tools I did not know about. So see, today I learned something. I could use this tool called the summary tools. The number of downloads is very high. So obviously a lot of other people have discovered it, and I was a bit in the dark. I still have to catch up on this, but I've been using the Data Explorer. So now you look at this article, we are doing exploratory data analysis, and is this useful? In fact, it is so useful, I will immediately go and print it out for myself. There we go. So you see that each of these libraries, they are explaining in detail and they are showing how to use these libraries, right? What do they give? They can, and these are powerful libraries. They're even doing your principal component analysis and so on and so forth. And all these libraries, DLooker, Expandr, and so forth. See what they do for you. A decision tree fitted using the explain tree. Certainly, it's something we could have used in the R version. I'm yet to release the R version. So now what will I do? I'll probably go and incorporate this work into the solution that I'm going to release. So that is the fun of it, guys. That you can keep on enriching your arsenal of tools that you use. Remember, we did a missing example guess function, displays types of each value in the data frame. This is the missing value analysis. If you remember, the missing no function in Python has it in black and white. Well, this does one better. You have it in color now. Isn't it? And so, well, in general, the R libraries tend to be a little bit more professional, a little bit more, because the statisticians take it a little bit more strict. Python is moving faster though. In deep learning, Python is the dominant king. Outside deep learning, I would say still R has a superiority over the Python part. So, which is why I should explore or release solutions in that also. So you see it here, right? Wonderful article, literally worth reading, guys. This world of data science is so rich with other people's hard work and the results of their hard work that it's any hour you give to reading these articles or journals is really time very well spent. So that explains, for example, this R journal. What I have done in this notice is all these things that I talk about, I've put it literally on the left, right? So then this is a curated list, the C10 task views. If you want to do something, let's say exploratory data analysis or regression or clustering, somebody has curated the best libraries available to do those tasks, has written a review and accumulated the best ones. So quite often you can shorten your exploratory, your web surfing time by just going here, picking up the ones from here. These are the respectable high quality libraries you can use for the task. Similarly for Python, first of all is there are all of these tutorials. Right? In the same tradition as R, Python is following that and coming up with fairly extensive documentation. I would say, compared to any of these software libraries, you would realize that Python and R both are documented to a much, much higher standard. A lot of effort is put in explaining them very, very clearly. Right? So that's the beauty of this subject. Anyway, I have put all the libraries that I use quite often, and I put it just next to it so that you can quickly refer to it. So do that. Well, glossary is rather sorely missing. The best definition that I have is for mathematics. I hope you'll agree that nothing beats this. Anyway, I'm joking, of course. So bibliography. So anyway, now I'll come back to
this.
Go ahead.
This document is available to us, like the one that's your book, right?
Were you doing ML100 this spring, or did you miss it?
Not this spring, way back when you.
Oh yes, I have not written it. I wrote it actually this spring itself.
Okay.
I'm sending it for publication at this moment. And if you guys, as I said, actually, I'm a bit behind. I promised people who want to purchase a copy of this. So you must have taken ML100 sometime in your past to be able to buy this book. And this book is going to publication, hopefully in another couple of weeks when I get a bit more time. But let me give you an idea. And I'll give it to whatever the printer charges. Let's say that the printer will charge.
Yeah.
I guess it's about $30. So whatever the reason for that is printing color is expensive. And data science is about colored diagrams, colored plots and graphs. So you can't avoid color in a data science book. Otherwise, black and white takes away half the charm of the book. So in color, it gets expensive. It's about $30, $40, whatever it is. At price, I'll make it available to you guys. So this is the book. Anyway, so I will go in particular to a chapter on. So this is anyway. So for those of you who haven't seen it, I'm putting it here. It's exploratory data analysis is what it is, and that's where what we'll do today in Python. So what do we do in exploratory data analysis? There are different ways of doing it. Single purpose, you write your pandas DataFrame .histoplot.histogram. So one by one, you do it in R, you would do hist. Or you use these automated data explorer tools. So far, guys, in the lab, which automated data explorer tool did we use? You guys remember which one did we use?
Profiling?
Yes, pandas profiling. You use that, right? So that is that. And then we have the concept of a data frame, which is fundamental. Once you have a data frame, the R data frame gives you some basic, very high value functions. You can call summary on it, string, pair, covariance, plots, etc. Pandas is not far behind. We just saw. So together, I would like to say that between pandas and R, there's a very, very close similarity, which is why knowing one, learning the other is a child's play. So a grammar of graphics, let's think through it. What does select do? Whenever you have data in a rectangular form, rows and columns, one thing you could do is keep some rows and throw away some other rows, isn't it? So that is the select. You're selecting some columns. Sorry, not throw away some rows, the columns. Keep some columns and throw away other columns. So select, very much like the select in SQL, does that. the technical word that you use is data projection. You're projecting it onto a subspace. If you think of it as a real valued n dimensional space, you're going to m dimensional space, which is smaller than the original space, by throwing away some of the features. Select will do that. Filter, what does filter do? Filter, very much like your SQL filter, you are saying, don't keep all the data, throw away some rows or instances of the data based on some criteria. So for example, if the temperature, if you're looking at a rainfall or something like that, throw away any data where rainfall seems to be greater than a certain amount, because maybe they are bad readings or accidental readings. For example, somebody has some data gatherer has gathered rainfall in a given day at something like 200 inches.
Huh?
Like 200 inches of rainfall in a given day. And therefore, you would say that those rows are bad rows. Let's go delete it. That could be a reason to filter. Or if you have data and you say, I'm just going to look at San Francisco. I don't care for other cities. And so you would say, you filter down to cities equal to San Francisco. Right? So that is a filtration of data. Mutation of data, you add things, features, columns, etc. That's a mutate. Arrange, this is your way of ordering, sorting and ordering data. Sorting is a classical example, right? You can arrange data by any other means that you choose, but sorting is by far the most common. You want to ascend or descend sort data, right? And in SQL, you realize that this is sort ascending, sort descending thing. Summarize the data is a way of getting descriptive statistics about it. Right? So that is summarize about it. Distinct just tells you, removes the duplicate rows. So sometimes people gather data and two people may, in the data set, if lots of people are gathering data, they'll have overlapping sets of data. So distinct will make sure that you have only unique rows of data. Count will count the number of rows. Then you can sample into the data. You can dip into the data and get a sample. Group by, we talked about group by. You can group by some feature value, for example, city. Right? Take all the temperatures of San Francisco and group them together. Inner join, left join, right join, and full join. Exact SQL equivalents. We just talked about it from the cheat sheet. Intersection, again, the same thing. Keep the common rows is the set operation. And the union and union all is again a ways of merging data frames. It turns out that these basic operations which are there in R are also exactly the operations that you have in Pandas. So that brings us to the concept. If you notice that, I was talking about these methods in R, dplyr, but they are exactly the same as the methods in Pandas. Do you see that, guys? When we reviewed Pandas, we were talking about exactly the same methods.
Yes.
Okay. Merge and so forth. Mutate, there in R it's called mutate. In Pandas it's called merge. So with minor name, syntactic differences, it is exactly the same. So today's topic will be, obviously, since this is a Python class, we'll keep it Pandas centric. So what is tidy data? Tidy data says, it's a philosophy about data. It says that if you can put data into a standard format, which follows some rules, then you will have ease of data manipulation. You can use a very small grammar and things will, you can manipulate it to handle with the data with ease. So this is a quote actually taken by Wickham himself when he wrote his paper. So this paper that he wrote, well, I didn't quote the paper itself, did I? I didn't. So, but this is his website. Let me click on that too. Yeah, tidy data. And irrespective of whether you work with R or Python, you should read or be familiar with this. So this book, guys, I've gathered all the important references that are really worth understanding in a given topic. So see if you can go back and review this book. I've shared it with all of you as a PDF, but yeah. So what is the basic, and I love this quote actually. The first quote is coming from Tolstoy, his book, Anna Karenina. Anna Karenina is a wonderful and rather heartbreaking story that Tolstoy wrote. Actually, the interesting thing is, if I remember right, Tolstoy fell in love with a girl, with a sweetheart, and they married. And in his days of greatest happiness and honeymoon, uh, pretty much around that time or during that time, he wrote one of the saddest books in human literature, the Anna Karenina. Very heartbreaking. And the book starts out with this sentence. It says, "Happy families are all alike. Every unhappy family is unhappy in its own way." It's a interesting way for a book to start. So then what Wickham is saying is tidy data sets are all alike. Means once you have data in a tidy form, it's right. But messy data sets are messy. Each messy data set is messy in its own way. And of course, the messy data sets give you no amount, I mean, endless amounts of headache. So the first job of a data scientist is to convert whatever data you get into the tidy format. It is surprising how many data scientists don't adhere to this principle. And I think this is because textbooks tend not to emphasize that. So they manipulate data in sort of a hacky way. So what we will do today is we will take the weather data set. This weather data set I've taken from the Kaggle website. You will notice that this data set comprises of many files. There is a file of cities which contains a city's country, which country the city belongs to, latitude, longitude. Right? We'll see that in Jupyter Notebooks in a moment, but let me give you a walkthrough of the query before we go into the Python code. Then all other CSVs are about one kind of weather observation. So the kinds of weather observations are temperature, humidity, I believe precipitation, wind speed, and something else. We'll find out. A few such observations are there. So when we look at this data, so first thing is, okay, here we go. Humidity, oh, pressure, I missed pressure. Oh, precipitation is not there. I take that back. Humidity, pressure, temperature, wind speed, wind direction. These are the 5 attributes. How do you read it in Python, guys? By now, this one is in R, so we haven't done it in Python, but I'll show it to you in Python in a moment. You read it like this. Did I give the Python version in this? Let me see. I think in this book, I may or may not have given the tidy data. Yes, the tidying data with Python. So let's look at the Python. Would you guys agree that to read data, by now, this syntax looks a no-brainer? Figure 212. Would you agree, guys, that this is a no-brainer? We are all used to reading data like this.
Yes.
So this is simple. What is the first thing you should do when you read the data? You just go and check how it looks, a few rows. So here, if you look at the first few rows, you realize you're in for a surprise, actually. This data looks a no-brainer. Vancouver, first column is city, country, latitude, longitude. I believe they have about 34 cities involved here. Now, just as an observation, we talked about it. Pandas has a native support for styling and customization. We talked about it, how you can customize your pandas. You see, I've changed the header and so forth, made it look a little bit prettier. But then that looks normal. But then you go and look at that thing, and you look at how the data is for cities. And you realize that the data for city is in the wide format. Wide format means let's go and see what it looks like in the notebook, weather data. So here it is. When you go here, let me increase the font a little bit. Is this now legible, guys, from in everybody's desktop? Looking
Yes.
big there? Okay. So when you look at this data, you look at the, so where we go. You look at the raw temperature. you do a descriptive statistics, you're surprised because what are the columns? Columns are the cities, right? And let's look at if you look at this data, I don't think I did a preview of this data here. If you look at this data and you do a preview, you'll realize that it is in like columns are the cities and the temperature on a given day, a row is a given day, and it gives you the temperature for that city on that. So the first thing you need to do is you need to put it in a standard format. We are being rather cryptic. Let us go and check it out. Let's take the data. Let's look at humidity. Huh? Let's look at humidity. Do you see something odd here? Daytime is the first column. Each of the city names is the column after that. And every day you have let's say a given date, and you have the values for it, humidity values for each of the cities. So now, if you think about it, does it follow into your tidy data format, which says that data should ideally be, what is the tidy data format saying? Data should ideally be in this format. The column should be sort of the observables or the features. It is not. The data is very wide there. Each of the city is along columns. So it violates this. And it says that for a given city or a given day, all the observations should be in one row. That is the tidy data format. Whereas what we are looking at here, where are we? Here is not in that format. You see that columns are not observables. They are instead dimensions. So, when people talk of dimensions and measures in data warehousing, there's a very close analogy. Here, the dimensions are there as columns, but the observations are there in the rows. So you want to change this data into a standard format. So guys, if this word wide format versus long format is not familiar, I would suggest go read my book or go to the Tidy Data website, make yourself familiar. When you did ML100 this spring, I covered it in a lot of detail, so I don't want to waste time repeating all of that. But if you have not, it is really important that you go and do that. Right? So what do? We take data and we want to put it in the right format. How do we do that? We take the data and we melt it. Right? Melt is a way to pivot the data. Right? In pandas, you pivot it by saying the row remains this, the variable which is which you want to create, right, is city, and then the value of the city, and the value name will be temperature. If you do that, the data becomes in this format. Do you see this is in a way a neater format? On a given day, in a given city, the observation was this. Does this make sense, guys? On a given day, in a given city, this was the observation. So these two are the dimensions, and this is the measure, the observation, right? And in data science, try to do it like that. Huh? Make sure that the dimensions are your column, and then your measure is right here. So if you do this for temperature, you can look at a few temperatures. You can do the same thing for other files also. So now what will you end up with? You would end up with a data frame like this, except that the next one will say humidity, the next one will say wind speed, the next will say wind direction, and so forth, right? So now that you have that, it is time to do a join, isn't it? Because what you want, in reality, you want that a data frame like this should have date time, city, temperature. Next column should be humidity, next column should be wind speed, the next column should be wind direction, and next column should be pressure, like things like that. And how do you do that? By joining on these two. Right? So let's go and once you have this, you notice that we are doing a join. Is this making sense, guys? So let's stare at this. This is a bit of a complex syntax. We are saying that the ID, the index of a row will be the date time from the original data. The new column we are creating is city, and a new value column that we are creating is the humidity or pressure or wind speed or so forth. So it will create the data into the long format from the byte format. So once again, please do review tidy data. It's important. I wish I had time to spend more time on this. But now what do we do? This is a simple join operation. So guys, let's go back to the pandas data set. This pandas thing, tidy. Do you see that I use melt? If you look at the cheat sheet, do you see me using melt? Isn't it? And
Yes.
followed by, once I have melt, I do join of the data, right? So how do I join the data? Somewhere here is a way to join. Let's go back and say a combined data set, right? So there are different syntaxes. This is merge, right? I could have used merge, or you could directly use the word dot join, which also is there. I think this one doesn't mention join, but you can directly use join, which is more appropriate here. Join, and then you have to just join on what? These two column attributes, and set index this. When you do that, you will get a combined weather data, which will look like this. So do you notice that all the columns have been joined? So in other words, data from all of the files have now been joined to this. Right? This data, we can do a cleanup if needed, drop null values. It turns out that you don't have null values. So 0 null values. Then you continue on. No, there are some null values here. So you drop the, so then you ask for, what do you do with the null values? Remember, one way is to drop it. You don't have some column value is missing, you drop the row. Sometimes you don't have to, especially for weather. You realize that the weather between 2 days are likely to be relatively similar. Temperature are likely to be similar. If the temperature value is missing for a given city, one easy thing that you could do is just interpolate between the 2 days. Are we together, guys? You can just interpolate the value of the day before and the day after. The temperature, if you guess that the temperature today is the average of the temperature yesterday and the temperature day after, the temperature tomorrow, you'd be fairly accurate. And that's what interpolate does.
Interpolate will fill up all the.
Yeah, it will
No,
fill up all of
really?
them except the first row. Because how do you interpolate in the first row? Right?
Yeah, there is no such. Yeah.
And so then you can drop that row. Yeah? This is the Python
If
syntax.
that happens to be, yeah.
Then you can rename. Here I do some cosmetics. I notice that temperature, these things have capital letters, and so I canonize the names so they all look a bit more uniform: date, time, city, temperature, etc., etc. And then here I'm just showing the top 7 rows of data. Suppose I want to filter down just to San Francisco. What will I do? This is the filtering. When you take a data frame and in brackets, you put the filtering criteria. What are you saying? Weather.city, the city column, must be San Francisco. Then this data frame will limit itself to only San Francisco. And so for San Francisco, we have so many data points. What can we do with these data points now? We can do further things. For example, uh, you can do what you want. For example, you can take the averages or whatnot. So here, what did we do? We did a restriction on the rows. We only want the rows associated with San Francisco. Alternatively, what we could have done is we could have said, I'm not interested with all of these attributes. Just give me city, temperature, humidity. Forget about wind speed and wind direction and pressure, right? Just give me these 4 columns. So how would you do that? You're all familiar with this. Remember, this is how we would create the X, the features vector, the feature matrix, and the Y target variable. We have done this in our notebooks, isn't it, guys? The river data set, the California housing data set. We have been, so this syntax is very common. You pick a few columns, you sample into a few rows. So now data is limited to these 4. Right? How do you find the average weather for each city? See how powerful the syntax is once the data is in tidy data format. You can say weather.group by city. So now you group by city. And then you say for each of these attributes, temperature, pressure, all of these, find the median. What is a median, guys? Do you remember? What is a median of a bunch of numbers?
The average, the center value.
It's
Yes,
like
you sort them, and the center value is the median, right? So there are 3 things: mean, median, mode. Just to refresh, a mean is take all the values and divide it by the number of data points. Average. Median is sort and pick the middle guy. What is mode?
Most frequent value.
The most frequent value. That's good. So that's mean, median, mode, and then there's standard deviation, variance, and so on.
so. Asif, just
Yes.
here we use like a bracket, right, around city, and sometime we use like that other bracket, right? I think there is a. Is that when you pass the argument, then they use the square bracket?
Let me just say, okay, here, this is, I wrote a rather cryptic syntax. Let me break open this box. So we have weather as a data frame. Group by is a function on that data frame.
Okay.
It's a group by city.
You're calling a function.
You're calling a function. So now what will we get? We will get a data frame in which for each city there'll be many values, right?
Yes.
And then what we are doing, we are saying that in that, pick only these columns, leave the other columns around, because that thing will still contain the city column and other things, right? So it says just pick these columns. This is very much like your
Passing an argument.
yeah. No, this is square bracket is a list of. Remember, the square bracket is always a list. In Python, square brackets produces a list. Now you're saying that from that data frame, pick these columns, right? And from these columns, find the median of these columns.
I see.
Now the thing is, you got the median. It is worth giving these medians some name, right? These medians that you found. So you say, okay, you know that the first one, second, what they each of them were, you give it the column names, because otherwise they were missing column names. You just gave it column names, and then this is just reset the index, means forget about the index column, the row ID column, reset it. And then you sort it by median. Let's say that you want to find from the hottest to the hottest place. Sort values. You can sort it by values in a given column, right? So when you do that, see, what do we get? So can you tell which is the coldest city and which is the hottest city? Coldest is Montreal, right? 281. What do you think the units of measurement are here? Anybody can guess? What are the units of measurement? What is the scientific unit of measurement of temperature?
It's Kelvin.
Kelvin, exactly. So these are Kelvin. So if this number looks huge in Fahrenheit, you have to remember that these are Kelvin. So 273 is 0 degrees. 0 degree Celsius or 32 degree Fahrenheit. So this basically, in terms of centigrades, it stands for median temperature being just 8 degrees centigrade throughout the year. You would imagine that if you live in 8 degrees centigrade median temperature, you would call it a rather cold place. Minneapolis also in US, as you know, is cold. Toronto is cold, right? And Seattle looks cold. Vancouver, all of these are up there. Detroit, these are up there. Northern cities, they are cold. On the other hand, let's go and see what are the hottest places. Miami. Miami is close to 300 degrees. Like temperatures are pretty high, isn't it? 27, 25 degrees centigrade median. Houston, you all would agree, Phoenix, Arizona, San Antonio. These are all fairly hot places. Tel Aviv certainly, and Jerusalem are in the Middle East. Those are really hot places. Haifa and all these are hot places. Right? So this is it. And the same thing, if you want to just prettify it, I just showed you how to prettify this thing. So guys, this is using pandas in Python to do data manipulation. The first time you encounter this, and I'm speaking to those of you for whom this is your first encounter with data manipulation, I would again remind you of the advice I gave in the orientation book, Pandas for Everyone. That book should be your primary text. Read it. Those chapters are easily digestible. Each chapter you can finish in 2-3 hours. There are, I believe, 16 or 20, 16 or 18 chapters or 20 chapters in that book. Every day, if you do one chapter, in 2-3 weeks, you would have finished the book. And just giving 2 hours or so to read one chapter in the book is not much. Do it, practice it. If you just read it, it's an hour. Practicing it will take you another hour. Correlation plot. How do you find, what is correlation? Correlation is how related are, how co-varying the the normalized values are. Once you z-value it, it gives you the covariance of two variables.
Asif, question.
Yes.
In line 23, Asif, when you set the index, is that assorted already? The city is already sorted?
Yeah, it is at this moment, it is already sorted.
And then you just reset the index from 0 to 20 to 30.
Yeah, so you reset the index. They reset index on the city. So, I mean, you make city itself the index. So do you notice that there is this index column here? Right?
Yes.
Okay, let me explain what to give you the context. It's 21 probably that you are referring to. Once you have done all of this, right, data, you have sorted the data. Remember, where did we sort the data? Here, you sort it by median temperature, right? So observe something. You have this index column. Pandas data frames will always have this index column. It is serving no purpose. It's just a row ID. What do you do about the row ID? It is unnecessary because you realize that a city, city is unique. In this table, city is the unique thing. So you don't need this. You could have made city the index. So 2 ways to deal with it. First is you can go and just say reset index. If you reset index, then you will see something like this. All right? 0, 1, 2, 3, if you look at the data. But actually, this index is unnecessary. So the next thing we do, and I'm just showing what all the things you can do. You say that, forget about these numbers. Let us declare that the city itself is the index. So I made city the index, right? You say, make city the index column and effectively get rid of the row number as the column, index column. Yeah? Every data frame has an index column. So make city the index column. You just got rid of one unnecessary column. Right? And so you can then go, and now that it became the index, you don't want to have an index and a city as a column also present. Now city column is useless. So you can go and drop the city column and your data then, if you sample into the data, you will see a slightly different behavior. Actually, there is something odd. If you run this, actually, this should have been city names. Here, you should see city names. So there's an error. I have to run this notebook. Did you get that, Patrick? You remember that? We did this in the last course.
Yes, Asif. My question is, Asif, if I sort and then I just put inside the sort ignore index equals true, and will that be the same output?
Yeah, it will do that. That will work too.
Okay.
So whether data now merge, remember I talked about left join, right join? Well, those joins are here as I'm using merge, left on, right on, right? So you could do that. City, right on city, you're merging. I could have just used join. I wanted to just show you the syntax for both left and right. Like you could use merge to do the join, or you could use literally weather.join if you want. So you're joining another table called the means, right? and the city table and so forth. So now all you are doing, and anyway, these are minor details. All we are doing is we had the mean temperature of all mean, etc., etc., of every city, right? Temperature is useless. Actually, these things are not. So temperature, you added the mean value. What is the use of this? Now I can compare the temperature of a given day versus the mean temperature of Vancouver. So what does it mean? On this day, which is 6th of March, 2014, are the temperatures below, actually it's not mean, it should be median. Are they below median or above median? They're below median. So it is a colder than normal day, isn't it? On that particular, and so forth. You can go about dealing with it like this. So this is data manipulation with pandas, guys. Huh? I've just given you a flavor of it. This notebook is available to you, and of course, this book is available online for all of you taking ML100 in spring. Soon you'll have a printed copy, all of you, if you are interested. Go review that. We are reaching a stage at which you know enough about the language. You need to learn about the library. So today was the day to do the pandas library. Pandas is very powerful. You know, this is a course in machine learning. So obviously we are focusing on the algorithm, but I thought we needed to give time to basic, the vocabulary of data manipulation. By the way, Prachi is maintaining the list of people who are interested in purchasing a copy of the book. Give her your name if you haven't given at some point, because if we make a group order with the printer, there is a discount they give if you order more than 5 copies or something. As an author, I don't get any discount. I mean, any extra discount. So we will all collectively order this book. I will keep a copy for myself. You guys will all get a copy yourself. It's an unfinished book. That's why I'm not fully publishing it. So you're essentially buying a draft or printing out a draft copy for yourself. So with that, guys, I don't have anything else. I'll take questions.
Hey, Asif, sir, this is Aritra. So this is very useful, but unfortunately, I didn't know about ML100 on time, so I couldn't take it at that time. So so for that reason, so I won't have access to the book,
No, it's
correct?
all right. You're taking ML200. I'll let you purchase the book, right? And I'll give you.
Okay, okay. Thank you so much.
Yeah. Though I must suggest, Aritra, that there are two things. First of all, you know that at support vectors, repeating a course is free. You know, you can repeat now ML200 as many times as you wish. Having said that, I would strongly suggest that whenever I offer ML100 at this moment, I don't know, maybe in fall, you may be
Yes.
doing that, registering for that.
Yes, I definitely want to do that, but yeah, that was my next question when you are going to offer the ML100.
I'm going to
So
offer the
it's next.
deep neural network. See, this batch, your batch,
Mhm,
I will
mhm.
take all the way through this deep learning and all that. Then I'll start the ML100 again.
Okay,
So
okay.
that will be much later, right, Asif?
Yes, that would be much later, 2-3 months.
So
Yes,
can we purchase the book till then and practice it?
yes, sure, I'll let you. I mean, if you have taken any course with me, I'll let you purchase the book.
Okay,
The
thank
thing
you.
I have taken at least.
Okay.
Asif, I just wanted you, if you could write, we did the training and test data here, right, in Python,
Training, how do you get the training and test
and
data?
test data in R, because I'm able to do it for single value. Like you would put xreg and yreg in the same line of code, right?
Oh,
In
right.
when we,
No, see,
yeah,
Python doesn't give you such an elegant syntax.
okay.
But I'll give you the best that I have, that I use. For
Okay, so it is okay to do it in single lines then.
yes, okay to do it in single line. So
Okay, okay.
basically what you do is you first define a set of random rows, then
Mm-hmm.
those rows, a subset of rows as your training data, and the other rows, not in that sample, as your test data. So in that matter is a little clumsy. For Python, that is scikit-learn. That's one of the crown jewels that you can split the data into test and train in a single line.
That's what I've been trying to do it, but yeah, I couldn't. Okay.
Yeah, it's not like that. So, all right, guys, I'll summarize what we learned. One thing is that I started out by saying in these notes that I've given you guys, obviously, I apologize to people who haven't taken ML100 to that. Just reminding you that there's a lot of references. Those references are very useful. Make use of the references. It is surprising even when you're reading email or doing something. If a reference card is just under your nose, you end up imbibing a lot of it. Those cheat sheets and those documents. The R journal is very good. It comes out periodically, and there are a lot of these articles that come out. One website that I like is Towards Data Science. I've mentioned that before. I have obviously no association with them. I, like you, am just another subscriber to it. I tend to like it, but I assume there must be other websites also devoted to this. But this one is pretty good, actually. So I think they charge me, if I remember right, they charge me a little bit of money to read all the articles, some $2-3 a month or something. So somebody told me that first few articles are free, and then after that you have to go into the incognito mode and you can still read it. I don't know. Personally, I like to support the site, so I actually like paying them and like sort of patronizing all the people who contribute articles, because apparently their model is that anytime you write an article on this site, and anybody can write, then based on the number of claps you get money. Maybe each clap is $1 or something like that. So people can actually make a bit of money by writing high quality data science articles and posting it. So this is another. So there are many such websites. Then some people like the Analytics Vidya a lot. It is filled with some good articles. You can try reading all that. YouTube is, of course, absolutely chock full of good videos. Right? You can refer to. More than that, the second thing we talked about was that data, it is worth having data in a tidy form. And for pandas, because today we were doing Python, pandas data frame, if you follow the tidy data syntax, right, you will realize that manipulating data with the pandas is both elegant, powerful, and easy. Right? You can do a lot with just a few lines of code. And you should always learn the right language or grammar of data manipulation. It helps you a lot going forward. People these days are in a hurry. They come into the field. The very first thing they want to do is, how do I write my first deep neural network? And in a way, it's sort of, you get onto the hot topic. It's exciting. It's exhilarating. But someday you should go back and fill in your basics. This is filling in the basics. All right, guys. So some data manipulation, and that's a summary. Go ahead, Patrick.
As if I have two tables that share the same, let's say city column.
Yes.
What's the quickest way to compare if they have the same amount of cities listed or the data is exactly the same, so that I can.
Oh, that's very easy. So see, if you want to see if the cities are the same, all you have to do is do dot unique. Like you can get the set. You can take the columns. All right. And
Not unique, as if like the exact same
same.
the exact same values in the exact same order.
Oh, want to do whether the two tables are exactly the same data. So first what I would do is I would sort both the tables. See, it's basically you should go like this. You sort the columns because somebody may have written the same data in different order. So you sort it in the same order. After the two things are sorted in the same order, then there are, I think data frames may have a way of comparing that I don't remember. It's a good question, actually. I don't know the exact answer to it. But one off the top of my head answer that I can give you is, I would sort both the data, write it out to CSV, and just do a diff on the CSV.
Okay, so as if what I did was I pushed the values to a NumPy array, and then I sorted it, and then I compared if the values of one table would equal the values of the other table.
Yeah, that is it. That's just as good. right? See, in DataFrame itself, you can write a little bit of code that will compare it column by column, right? Once you have sorted the data, it will compare it column by column because each column of data is a series, right? And you can say on the series, you can check if two series are equal. Series is nothing but a wraparound NumPy array. And you can check if those two arrays are the same. So you can iterate over all the columns and just verify that.
Okay, thank you. I thought there was a one line to do it, but
I think
yeah.
there was. Maybe there is. This question that you asked is very interesting. It didn't occur to me. Very good question. Let's explore it. Compare to data frames, pandas, data frames, or differences. Quick tip. Here it is. Somebody has actually
There's
done
if is always works. If this is
data frame reset. Okay, here's the data frame 1, data frame 2. You concatenate the two data frames, reset the index, then you group by list of DF columns. So you group by those columns, 1, 2, 3. And now this is a more complicated code. I think compare two data frames and output the differences side by side. Somebody else has, yeah, not equal. So this is it. Yeah, this is really the shortest syntax. What you do is you take the data frame and you take only those rows which differ, right? Where something is different, not equal, right? And then you produce it. That is it. So yes, this is the way. It's so nice. I learned something. Let me paste it in the chat. Should I?
yes.
This is on Slack, on Stack Overflow. So it's a very good question, and this is an elegant answer, I suppose, to that. It does it in one line. Likewise,
Can't we use join, Asif? No.
Join would not be the best way of comparing, no?
Asif, if you go to the
Right.
pandas cheat sheet.
Pandas cheat sheet.
Yeah, so on the second page, combined data set. So the CA, so that is the difference. So if you combine data sheet, the last one.
All rows that do not have a match. Yes,
Yeah.
yes, you're right. Yes, thank you for pointing this right here. There's another way of doing it. You just say all the rows, but this is only on a column. The trouble with this is, Anil, this is only on a column basis.
So you're comparing the first column to the second column. Yeah.
So yeah, that is it. So you'll have to write a sort of a for loop to iterate over the columns. That also does. See, that is the approach I was thinking about. But this one seems even more elegant. It just if data frame not equal to data frame 2, which means that data frame's pandas data frame is pretty smart. Internally, it will do the comparisons for you, isn't it? And so look at this syntax. Very, very elegant. I didn't know that. In one line, you can find that.
Like both approaches. Thank you, Anil. Thank you, Asif.
Yes. Very. And people have added more and more to it. Very nice. All right, guys. So that is it for today. Any questions? Was it useful, by the way, this Panda stuff?
Yeah, very useful, Asif. It seems like data frame just takes value on its face, right? Just integer, character, and whatever it is, store as it is, right?
Right. Actually, this concept of data frames, the way it is very well articulated in R and in Python, and somebody was telling me that these two communities have joined forces now, so that the syntax is even closer to each other.
Yes.
So, but it's a huge thing. Imagine doing it in C, C++, Java. It's much harder. And there's a reason. If you look at Spark, the first version used RDD, Resilient Distributed Data Sets. But then the second version was based on data frames. Data frames are a very powerful construct. And today, in most of the things that you do with Spark, you can just write it as SQL. So that is their data manipulation language. You can just write it as Spark SQL. You load the data as a data set, as a data frame, and then most of the data manipulation is just SQL. And most of the world of reporting and business intelligence is just that.
That's very powerful. Yeah.
Or the group buys and so forth. So you can do it very elegantly now instead of writing tons of code.
You just
Anything else, guys?
no, Asif, that's very useful. Thanks a lot.
Okay. So this recording, remember, I'll stop the recording now. It is all live, so therefore it is there on YouTube already. As you, if you want to go back, because we went over some material a little bit fast. And what else do we do now? All right, guys, so if you don't have any questions, I will end this session. Thank you for being here. Let's take up tomorrow. Tomorrow, yes, we have a new topic. We will do boosting, and we'll follow boosting with, we'll follow boosting with what? With support vector machines, with kernel machines.
Thank you.
Yes, bye, guys.
Thank you so much.
Bye.
Thank you, Asif. Asif, when do you have time for consultation?
When do I have time? Tuesday is a bit more open. Should we keep it Tuesday evening?
Okay, Asif. I don't need too much time. I just needed to run through the code just to see if the thought process is okay. But more or less, I understand the code.
Nice.
So
yeah, let's keep it for Tuesday.
Okay, thank you. Tuesday, I'll send you an email. Thank you.
Bye, guys.
Thank you, Asif.
You're welcome.